Hello and welcome, my fellow learners, tech enthusiasts, and curious minds. I'm thrilled to invite you to a fascinating exploration of one of the most transformative technologies shaping our world today: the natural language processing, machine learning, deep learning, and transformer. And more importantly, how these seemingly complex concepts are interconnected to power the intelligent system we use every day. If you have ever asked Siri a question, translated a document using Google Translate, chatted with a bot or a website, or marveled at how ChatGPT seems to understand your questions so well, you have already witnessed the magic of this technology in action. But how does it all actually work? In this video, we'll peel back the layer and break down this topic into simple, digestible insight that will empower you to understand not just the what, but the how and why. We'll start with natural language processing, or NLP, the bridge between humans and machine. You learn how computers process human language, decipher meanings, and respond intelligently. From text classification to sentiment analysis and real time language translations, NLP is at the heart of modern AI applications. Then we zoom out to the bigger picture, the machine learning, the foundational discipline that gives systems the ability to learn from data. You'll discover how ML enables systems to improve over time, adapt to new inputs, and make prediction from spam filters to recommendation engines. As we dive deeper, we encounter deep learning, a powerful branch of machine learning inspired by the human brain. Deep learning uses neural networks with multiple layers to model complex patterns. You'll understand how deep learning has become essential in tasks like voice recognition, image analysis, and especially in understanding the context and the emotion in human language. And then comes the real game changer: transformers. These deep learning architectures have revolutionized NLP by allowing models to process language more efficiently and with greater contextual understanding. We'll explore how transformers using mechanisms like self attention have powered landmark models like BERT, GPT, and the incredible engine behind ChatGPT. Throughout the video, we will connect the dots between these technologies. You will see how machine learning forms the foundation. Deep learning scales it with advanced neural network. NLP applies it to human language, and transformers take it to a whole new level with unparalleled performance. Whether you're a student looking to build a career in AI, a tech professional trying to stay ahead of the curve, or just someone fascinated by how machines understand us, this video is your perfect starting point. So grab a notebook, hit play, and let's decode the intelligence behind modern AI together. So don't forget to like, share, and subscribe to stay updated with more deep dive content into emerging technologies that are reshaping our future. I'll see you in the video. This is your host, Savit Vittal Salian. Let's look at the topics that we are going to cover as part of this video. Starting off with introduction, then we'll go into NLP, the common task in NLP, then we'll touch on deep learning, then we'll look at deep learning models common in NLP, then we'll touch on what is machine learning, then we'll go deeper in ML and how it connects with NLPs and DL, what are transformers in NLP, and then we will touch base on transformers in ChatGPT. We'll end up with a conclusion. So that's the summary of the topics that we are going to cover in this video. NLP. What is natural language processing, or NLP? Natural language processing, or NLP, is a subfield of artificial intelligence or AI, which focuses on enabling machine to understand, interpret, generate, and respond to human language in a way that is meaningful and useful. So, for any student or one who wants to understand how this all works, do remember the four keywords here: understand, then interpret, then generate, and respond to human language. Now, here, human language is termed as natural. Hence, in the NLP, the natural is equal to human language. Okay? So that's a context here. The core goal of NLP is about understanding the syntax and the semantic of a language. Syntax is what we know as grammar, and semantic is what we know as meaning. So I hope we are clear on these terms. This would be useful as you move deeper into the subject. Hence, for clarity, for any students who wants to get a base correct, this is a critical slide. You can pause this, read through it again so that you know where we are entering. Second goal is to enable machine translation, speech recognition, text classification, and sentiment analysis. The third goal of NLP is allow machine to perform human-like conversation, summarization, and question answering. So this is what NLP is all about. Common task in NLP. We have few. Let's go through them. The first is text classification. We can correlate this with what we know about spam detection example. So you have clarity about when we say text classification, what it looks like. Second is named entity recognition. This is about identifying names, place, dates, etc. The third task is machine translation. Example in this case is converting from one language to another. Example in this case, we have taken English to French translation. That's machine translation. Part of speech tagging. This is identifying the verbs, the nouns, etc. Question answering. It's about responding to factual queries. This is something that we deal with. When we have query, we type it out and we try to get the best answer or the right answer. So that's question answering task in NLP. Text summarization. This is about generating concise document summaries. Again, this is something which we use now more frequently than earlier, wherein we have a big chunk of documents. We want our tool to review the whole thing and give a short summary of 500 words. So that's text summarization. And the last is conversational AI, which is about powering chatbots like ChatGPT. So we'll go to that in detail in future. So these are the common tasks in NLP. Deep learning. What is deep learning? Deep learning is a branch of machine learning based on artificial neural networks that learns from large volume of data, and it uses multiple layer of computation to model complex patterns. Now the key is uses multiple layer of computation, hence it is deep. So when you hear deep learning, this is the background on why it is known as deep learning. We put it from the other side, uses multiple layer of computation for a large volume of data based on artificial neural networks, and it's a branch of machine learning, and that's what deep learning is all about. You can pause the video, go through this again so that you have clarity. Now, why it is powerful? It learns hierarchical representation. Example, from character to words to sentence and context. It scales with data and compute power. Means more the data, the better it becomes. More the powerful is the engine, the better it becomes. So it feeds on data. The more you give it, the more refined it is, the more accurate it becomes, It reduces need for manual feature engineering. So as the data increases, as the base increases, the accuracy increases. So that's deep learning in a nutshell. Let's look at the common models of deep learning in NLP. There are four for this conversation. The first one is the recurrent neural net, which is more of a sequential model for short text. The next is the improved RNN for long dependency for a longer sentence in a simple terms. Then comes the CNN. Now, what's CNN? The CNN is about capture n-gram feature in test. Now, what's n-gram? N-gram is a continuous sequence of items, typically words, characters, or other token extracted from the text or speech. Now, why n-gram is useful? Well, actually, it captures the text, its relationship between each words and patterns in a text. Hence, it makes it very useful for NLP. It is able to capture the pattern. So that's where the n-gram feature helps. And the last, which is the current state, which is the transformer model, which is state of the art, and as we just discussed earlier, it works parallel, hence faster, more efficient. Now, if we come to the next one, how is NLP and deep learning linked? Well, deep learning is now the backbone for modern NLP. If you look at the sequence, well, the current approach is deep learning plus NLP. It is, as we know, high performance and reduces the manual work, which was the case in the previous approaches. But it was evaluation. It started off with rule based NLP, then statistical NLP, then classic machine learning. Started off with the limitation. Initially, it was inflexible, brittle. Then it improved itself into larger label data sheets. Then limited generalization. And now where we are. So that's how the connection is. That is how the deep learning and NLP are linked. How does deep learning enhances NLP? There are four ways. The first is end-to-end learning. Second, contextual understanding. Third, scalability. Fourth, multimodality. End-to-end learning is about learning directly from the data, all its features. In contextual understanding, it uses words, embeddings, and attention mechanism, the spirit of it. The scalability is all about how big a data it can train. In this case, it can train on terabits of data and it is ever increasing. And multimodality, it's about combining multiple modes which include the text, the images, or the audio, which we know now. Example is the GPT-4. So that's how deep learning enhances the NLP. Example in this case we have taken is the chat GPT, which includes deep learning and NLP combined. If that's how the feature is today. Chat GPT is a deep learning powered NLP model based on the transformer architecture. We discussed this earlier in the slide. It can understand and generate human like text, handle complex dialogues, translate, summarize, and analyze languages. So that should help you get into the context of how enhancement happens to NLP. Let's look at the summary. From an aspect perspective, NLP is all about understanding the language. Deep learning is about pattern recognition from the data. When combined together, what you have is an automated human like language task. From a technique perspective, NLP is about grammar, rules, tokenization. Deep learning is about the neural network, the CNN, RNN transformers, which we discussed before. When combined together, it is end-to-end scalable NLP systems. From an output perspective, NLP is about pause tags, entities, and summaries. What's pause? Pause tagging or part of speech, that's POS, part of speech tagging, is the process of labeling each word in a sentence with its grammatical category, such as a noun or a verb or an adjective. So, in a sentence, every word is tagged to that category. It is a fundamental step in understanding the structure and meaning of a text, enabling machines to analyze the role of each word within a sentence. So that's a part of speech or pause tags. Deep learning output is prediction, which we know. When combined together, what you have is a chatbot, a translation, or a summarization service. Example use case NLP, text analysis, translation. Deep learning, image recognition, NLP, speech. When combined, what you have is Chat GPT, BERT, Google Translate, and so on. I hope this gives you a context of the combination, what happens when NLP and deep learning combine together in this three aspect of focus, technique, and output. Machine learning. And how does it connect with natural language processing or NLP and deep learning? What is machine learning? Machine learning is a subset of artificial intelligence that enables computers to learn from data and improve their performances without being explicitly programmed. The idea is that systems can automatically identify patterns and make decisions with minimal human intervention. Do focus on the two areas where I marked it as red and underlined. It's about learning from the data and improve without being explicitly programmed. This is what machine learning is all about. Do remember this too, it helps with the clarity and you have a very solid base when discussions on ML is in play. Now the conversation would be what are the different types of machine learning? There are four: supervised, unsupervised, reinforcement, and self-supervised learning. Supervised learning are based on labeled data. The learning is through the labeled data. The unsupervised ones are the ones which try to find hidden pattern in the unlabeled data, finding the hidden patterns. Reinforcement is learning through trial and error, and self-supervised is using structure of data itself to create training signals. As an example, for self-supervised it is GPT. For reinforcement learning, it's about the gaming AI, robotics. For unsupervised, it's about topic modeling, clustering documents, and supervised is about spam detection and sentiment analysis. Let's now look at how machine learning links to NLP. We know by now NLP involves understanding and generating human language. NLP uses machine learning techniques. It uses it for classifying the text, cluster similar documents, predict the next word in a sentence, and translate between languages. To break it further, let's look at NLP task against the machine learning methods used. For text classification, logistic regression, naive Bayes, and SVM methods from ML are used. For named entity recognition, the CRF, LSTM are used. For topic modeling, unsupervised LDA are used. For language modeling, self-supervised BERT or GPT are used. Let's now look at how machine learning connects to deep learning. Deep learning is a subset of machine learning. It uses an architecture called as artificial neural network. In particular, deep neural network to solve the problems that are hard for traditional machine learning. The approach used by machine learning is manual, whereas deep learning is automatic feature learning. The data requirement for machine learning is small to medium data, whereas deep learning requires large data sheets. Example for machine learning are decision trees, SVMs, and KNN. For deep learning, it is CNN, RNN, transformers, example the GPTs. Let's now look at Machine learning, deep learning, and NLP. How are they interconnecting? From a machine learning perspective, the role in the ecosystem is foundation that powers prediction, classification, and pattern recognition. That's for machine learning. From deep learning perspective, it's about advanced machine learning techniques that powers large-scale NLP systems. And NLP, it's the application domain where machine learning and deep learning is used to understand languages. To note, all deep learning is machine learning, but not all machine learning is deep learning. This is a note so that this is very clear how the interconnections are. In summary, let's look at the chat GPT. This is the visual analogy on how the whole thing fits in. NLP application, deep learning, traditional ML, and at the top, artificial intelligence. You can pause the screen, try to understand how it's all connected, take a note before we move on. Let's now look at the concept, definition, and the role. From a machine learning perspective, it enables systems to learn from data. Its role is to power algorithms for classification and prediction. From a deep learning perspective, it's a subset of machine learning using neural networks. Powers large-scale language models like GPT. From an NLP perspective, it is focused on understanding the language. The role is the domain where machine learning and deep learning techniques are applied. Let's now look at transformers. What are transformers in NLP? Transformers are revolutionary architecture in natural language processing that have dramatically improved how machines understand and generates human language. Transformers are a type of deep learning model architecture. It was introduced in the landmark paper known as Attention is All You Need by Mr. Vaswani et al. In 2017. Unlike previous models like RNN and LSTMs, transformers can process entire sequence of data simultaneously, a sort of parallel processing, enabling faster and more powerful natural language understanding and generation. Let's now look at the key features of transformers. First, attention mechanism. It helps the model decide which words in a sentence to focus on when producing an output. Second, self-attention. Each word attends to every other word in the sentence to understand the context, very much like human. Positional encoding. Since transformers process all words at once, they use positional encoding to retain the word order. Parallelization. Unlike RNN, transformers allow simultaneous computation over entire sequence, thus improving the speed. From a scalability perspective, can handle extremely large data sets and models. Example, GPT-3 had 175 billion parameters. Now what does 175 billion parameter mean? It means this many parameters, trainable parameters. This makes it one of the largest language models ever built at the time it was released. These parameters are distributed across multiple layers. GPT-3 has 96 such layers with dense connection between them. Now you know why we have such complex questions been answered so fast. This is the back end of work that is going on. Imagine through 96 layers of parallel processing happening for a single query that you would have put up, able to process 175 billion parameters. Let's now look at how transformer work in simple steps. Step 1. Input sentence is tokenized into words, subwords. Each token is converted into an embedding vector. Third, positional encoding is added. Fourth, Self-attesting attention layers determine how much focus to give each word based on others. Outputs are passed through feed-forward networks, and final layer output probabilities for next token or classification. Now, why are transformers important in NLP? First, long range context. Typically, it means it understands the relationship between distant words in text. It's much faster to train and infer compared to sequential models. It powers models like BERT, GPT, T5, and XLNet. It works for translation, summarization, question and answers, chatbots, etc. Let's now look at some popular transformer based NLP models. The BERT, it's an encoder, uses for text classification and entity recognition. GPT, it's a decoder for text generation, chatbot. T5, it's an encoder and decoder, text to text task, translation, summarization. Roberta, it's an encoder, more robust variant of BERT. Now let's look at transformers in ChatGPT. ChatGPT is based on GPT architecture, which uses the decoder half of transformer. It generates text one token at a time using previously generated tokens as context and powered by casual self-attention. Let's look at the transformer feature in comparison to the aspect. From a parallel processing perspective, yes, it handles entire sequence at once. From a handle context perspective, it's via self-attention. From a training speed, it's faster than RNN and LSTMs. From an architecture perspective, stack of encoders or decoders layer. From an impact perspective, it's foundation of most modern NLP models. What is the meaning of ChatGPT uses the decoder half of transformer? It means ChatGPT is a large language model that is built on GPT architecture. And this architecture itself is a simplified version of the full transformer model. Specifically, the GPT model only uses the decoder portion of the transformer, discarding the encoder part. So that is what decoder half of the transformers means in the sentence. Hence, in conclusion, natural language processing is a subfield of artificial intelligence focused on enabling machines to understand, interpret, generate, and interact using human languages. NLP bridges the gap between human communication and computer understanding. It underpins many modern applications like chatbots, language translations, sentiment analysis, summarization, and voice assistance. Typical NLP tasks include tokenization, part of speech tagging, named entity recognition, machine translation, and question answering. Machine learning is a broader AI discipline that enables system to learn from data and improve performance over time without being explicitly programmed. Machine learning uses statistical techniques to discover patterns and make prediction or decisions. It underlines many NLP systems by providing algorithms to classify, cluster, and extract meaning from text. ML is typically categorized into supervised, unsupervised, reinforced, and self supervised learning. In NLP, traditional ML methods like decision tree, support vector mechanism, and naive bias were historically used for tasks like spam detection and topic classification. Deep learning is a specialized branch of machine learning that uses artificial neural networks with many layers, hence called as deep, to model complex patterns in a large data set. Deep learning excels at automatically learning features from raw data, removing the need for manual feature engineering. It is particularly effective in NLP for understanding nuances in language, context, and semantics. Deep learning techniques such as the recurrent neural network or RNN, long short term memory or LSTM, and more recently, transformers have revolutionized NLP by enabling tasks like language modeling, text generation, and machine translation at scale. Transformers are a deep learning architecture introduced in 2017 that fundamentally changed the landscape of NLP. Unlike RNN, which processes sequence one step at a time, transformers can process an entire sentence in parallel using a mechanism called as self-attention, allowing the model to weigh the importance of each word relative to others in a sentence. This innovation led to a significant boost in accuracy and training speed. Transformers are the foundation of today's most advanced NLP models, such as BERT, GPT, T5, and XLNet. Hence, ML is the foundation providing learning algorithms to develop predictive models. DL is a powerful approach within ML using neural networks to handle large scale complex data, especially in NLP. NLP is the application domain where ML and DL are used to process and understand human language. Transformers are the state of the art DL models that have become the core architecture of advanced NLP tasks. Hence, in conclusion, finally, these technologies together power intelligent systems capable of translating languages, generating human like text, summarizing documents, and engaging in conversation, exemplified by models like ChatGPT, which uses transformer trained through deep learning within an NLP framework. With this, we have come to the end of this short video. I'd like to thank you for staying with me till now. I hope this session would have helped you get a perspective on natural language processing, deep learning, machine learning, and transformers. I wish you all the best to use this knowledge for future videos and in your own working. Thank you very much. Take care. Have a great day. Namaskar.